Let's look at an example. We need to evaluate the following integral. Let's first look at part A. Integral of 1 over square root of 49 minus 9x squared dx. I'm going to focus on the square root part and try to analyze it and see which substitution we're going to use. First, I'm going to rewrite it such that it's easier for me to identify what's my a and what's my x. We can see that I can rewrite it as 7 squared minus 3x whole thing squared. And hopefully you can realize this is in the form of a squared minus, let's call it heart square. As we talked about it in a concept video, you can consider it as 1 minus something squared need to equals to a thing squared. And I can see that, well, you can either set it up as a sine theta or a cosine theta. Either one is fine. So let's do that. Remember my heart or 3x here is 1 unit, so let's set the whole thing 3x as 7 is my a, so set it as 7 sine theta, for example. Okay, if I set it as sine theta, then I need to consider where cosine theta is positive or non-negative, so I can draw Castro. All students take calculus, and I can see that, well, this part is where my cosine is going to be positive, so theta is in between negative pi over 2 to pi over 2. Now let's do the substitution. Before that, I'm gonna take derivative first, so you can say x is 7 over 3 sine theta, which means dx is 7 over 3 cosine theta d theta. And I can replace the whole thing, so 49 minus 9x squared is square root of 49 minus, so 3x whole thing becomes 7 sine theta squared, so that's 49 sine theta squared. And I can factor out my 49 here. That's gonna be 1 minus sine theta squared. And again, using the trig identity, we can rewrite the 1 minus sine theta squared as cosine theta squared. So that becomes 49 times cosine theta squared, which is basically, if you don't understand, you can consider it as 7 times cosine theta whole thing squared. Okay, so this is equivalent to absolute value of 7 cosine theta. And because I set my theta in this range where my cosine is going to be positive, so I can remove it directly. So this is basically 7 cosine theta, because my theta is in this interval. Alright, now I can change my whole integral. So my integral 1 over square root of 49 minus 9x squared dx is going to become 1 over square root is gone, 1 over 7 cosine theta. And then this dx, we know that it's this, so let's replace it. So times dx is 7 over 3 cosine theta d theta. And simplify this, so this is gone. I have 1 over 3, and those two cancel out as well, so eventually I just have 1 over 3 d theta. And take the integral, that's gonna be 1 over 3 theta plus a constant. However, we're not done yet because my original integral is in terms of x, which means I need to change this back to x. So let me write it down. So it's important to sub my x back there. So sub x back here such that my final answer is in terms of x. So now my goal is I need to figure out what is my theta in terms of x. So back to the original here, or actually using the second line is easier. So back to here, you can see that x equals to this. Then I can figure out what my theta is in terms of x. Maybe I'll move it around. So again, this is equivalent to, I'm going to move the whole 7 over 3 to the other side. So that's going to be 3 over 7x equals to sine theta. Okay, and now if you want to know what theta is, then theta is going to be arc sine 3 over 7x. That's by definition. Okay, so now we can replace this back. So that's going to be 1 over 3 arc sine 3 over 7x plus c. And that is my final answer.